Okay, so I will show you different kinds of sequences. First of all, starting with arithmetic sequences. Let's say we have a pattern here building up with matchsticks. This is actually my third third pattern because I'm trying to make triangles, and you can see that at first I would have just one triangle, then I'm adding some matchsticks to make two triangles, and then eventually three triangles. So if I have just one triangle, I have obviously three matchsticks. Two triangles would be five matchsticks. And if you count the matchsticks here, I have 7 matchsticks. If you then look at this one here, there would be 2 more added. I have 9 matchsticks. And for the fifth pattern, I have 11 matchsticks. So let's call n the position, the number of the pattern in the sequence. Okay, and let's call the term the number of matches in each of the columns. Notice that to get from one number to the next, I am adding 2 every step. Plus 2, plus 2, plus 2, plus 2. A sequence where I'm always adding the same number or subtracting the same number is called an arithmetic sequence. So if I'm looking for the 6th term in the sequence, I again need to be adding 2. That won't be difficult to find, and I'm getting 13 here. However, to find the 20th term in the sequence, that will be a much harder thing. In order to do that, I need to start looking across from 1 to 3, from 2 to 5, from 3 to 7, etc. What can I find a relationship that leads me always in the same way from the n, the position in the sequence, to the term in the sequence? So I'm looking for a formula that will do that for me. I will call it the nth term, because the nth term is any position in the sequence. So, in an arithmetic sequence, the formula will be linear like this, and this is my variable. It will depend on n. I just need to find the value of a and b. Because I'm adding 2 every time, the sequence that typically goes up into is of course the 2 times table. The 2 times table. And so that's an indication that the coefficient that n is multiplied with will be 2. I will need 2n, because if I replace n with 1, 2, 3, 4, etc., I'm getting the 2 times table 2, 4, 6, 8. But my sequence doesn't go 2, 4, 6, 8. It goes 3, 5, 7, 9. It is 1 more always than the timetable. So I need to be adding 1 here. I can check if this formula 2n plus 1 is correct by substituting different values for n here in red. Let's check. 2 times 1 plus 1 is 2 times 1, 2 plus 1 is 3. 2 times 2 plus 1 is 5. 2 times 3, 6, plus 1 is 7. 2 times 4, 8, plus 1 is 9. And so by comparing here with the table over here, you can see that this works fine. So to summarize, I have been checking what is the constant pattern here, what is the number that I'm adding every single time. Okay, that has translated into a coefficient, into the coefficient that n is multiplied with, and after that I need to see how I need to correct that sequence by adding or subtracting something. I can now also check or use my formula to find out the value I didn't know here for 20. by doing 2 times 20, I'm substituting into this formula 2 times 20 plus 1. That is going to be 41. And so that value has to be 41 here. Okay, so let's repeat this on another example quickly. Here's a sequence, 3, 8, 13, 8, 18. I see that every time I go up by 5. And so I know that in my nth term, an plus b, this value here has to be 5, so 5n. And now I need to see what am I adding or subtracting if b is negative. Okay, well 5n would give 5, 50, 10, 15, 20. If n is 1, 2, 3 or 4, you can see, well, my first one's 3 instead of 5, my second one is 8 instead of 10, 13 instead of 15. It's always 2 less, and so my nth term is 5n minus 2. And I can complete this like that. T of n is equal to 5n minus 2. That is my nth term.